The velocity of a particle moving along a line is given by 3t plus 5 at time t. At time 1, the particle's position is at 4, whatever that is, 4 feet, 4 meters, whatever, miles, it doesn't matter. Where's the particle at time 10? Okay. So here's what we've got. We've got the velocity function. So we know velocity as a function of t is equal to 3t plus 5. We also know that to get the position, okay, which we'll call s of t, to get the position as a function of t, if we differentiate position, if we take the derivative of position, we get velocity. So s prime of t is the velocity. So we want to find the position function because we want to know the position at time 10. So what we have to do is find an antiderivative of the velocity function. We need to work backward. So we need a function that when we differentiate, we get 3t plus 5. So let's work on both of these. This function right here, to go backward, so let's just reason this out. To go backward, I would have to, the idea would be to make this squared, so that when I drop the power down and I differentiate this, I get something that's back here. But notice that I'm twice as much as I should be. So what I'm going to do is I'm going to divide by 2. So if we differentiate this guy, we get 2 times 3, which is 6t over 2, which leads to 3t. So the derivative of this gives me this. So position must be 3t squared over 2. Now let's work with the 5. So the 5, if we work backward, if we write 5t and we take the derivative of this, we end up with just 5. So that's a pretty easy one to do. So this is going to be plus 5t. Now the question here, this is a potential candidate for velocity. However, we don't know what the guy back here is, the plus c. And that's what we would like to know, is what is plus c? What is the possible value for the constant at the end? Because this is the whole family, one of these guys, for there's one value of c that when I differentiate this, I get this, and it also matches the rest of the stuff in my story problem. So what it says is that at time 1, so the position at time 1 should be equal to 4. That means this guy should be equal to 4. Now, that's at time 1, so let's plug in a 1 here. I just keep writing the t down. There we go. Okay, over to plus 5 times 1 plus c. c is what I don't know. So we're going to solve this. So what I'm going to do is I'm going to simplify this. So this would be 4 is equal to 3 halves plus 5 plus c. I don't like working with fractions, so I'm going to multiply everything by 2. 8 is equal to 3 plus 10 plus c. 3 plus 10 is 13. So c must be negative 5. Okay, so let's go ahead and just, that doesn't look right. Let's go back and check this again. Multiplied everything by 2. And let's see here, I got 8, I got 3, 5. Oh, I needed a 2c. That looks better. So 2c is negative 5. So c must be negative 2.5. Let's just check that out. So we believe that this guy is minus 2.5. So let's verify that. If I were to plug in s at 1, the position at 1 should be equal to 4. So that's 3 times 1 squared over 2 plus 5 times 1 minus 2.5. So this will give me 3 halves plus 5 minus 2.5. So 3 halves is 1.5. And so this will give me 6.5 minus 2.5 That's 4. It checks. So we've got the right C value. Now the question is, what is the position at time 10? Well, we have the position function now. It's right here. So let's go ahead and plug that in. So the position at time 10 is 3 times 10 squared over 2 plus 5 times 10 minus 2.5. So the particle's position at time 10 is 3 times 100, or 300 over 2, which is going to be 150, plus 50 minus 2.5. So 150 plus 50, whoops, minus, I'll just have to erase that, minus 2.5, that is 250. Oh, it's not 250, it's 200, sorry. It's been a long morning already working these videos. So 200 minus 2.5, it gives me 197.5, and whatever that happens to be, if it's in feet or whatever this is. But this is the position. So feet, meters, miles, who cares? It doesn't really matter. This is our position at time t. So the idea is take your velocity function, work in reverse using the antiderivative. Okay, so differentiate backwards. So we'll reverse the differentiation process. We'll find our new function. We'll have the c guy at the end that we don't know, but we'll use the information in the problem to find c, and then that allows us to plug in the position value that we're trying to find.